I want to take a look at a couple more functions and their difference quotients, specifically because different types of functions often will have different sorts of tricks that we need to do to simplify the result when we're looking for the difference quotient. So let's take a look at two more examples. The first one I want to look at is f of x equals 1 over x. So if we use the difference quotient here to figure out what this is going to be, we're going to end up with 1 over x plus h, because that's going to be f of x plus h, right? F of x takes 1 over x, so f of x plus h is going to be 1 over x plus h. And then it's going to be minus 1 over x all over h. We can't leave it like this. We've got fractions inside of fractions. That is a complex fraction, and we can't leave our answers like that. So what we need to do is we need to multiply the numerator and denominator by the least common denominator of the fractions inside of this bigger fraction. And so in this case, the denominators are x plus h and x. We don't worry about h because h is technically h over 1. So what we need to do is we need to multiply the top and bottom of this by x plus h times x. And that's going to get rid of those denominators. So we're going to multiply the top and bottom by x plus h times x. In the denominator, we don't actually need the 1. We just have x times h times x plus h. That simplifies. Now in the numerator, when we multiply these into the first fraction, the x plus h's cancel, because we've got an x plus h in the denominator and 1 out front. So those cancel, and then we just have x times 1, which is x. And then we've got this subtraction. And then when we multiply these into the second fraction, it's the x's that cancel, and we're left with x plus h times 1. So this is minus the quantity x plus h. All right. Now we need to distribute this subtraction in the numerator. So that's going to give us x minus h, because we're distributing that subtraction all over x h times x plus h. And then in the numerator, we can see that the x's are going to cancel because x minus x is 0. So that leaves us with the opposite of h in the numerator, and then x times h times x plus h in the denominator. And we've got a factor of h in the top and bottom that can be canceled out. And so when we cancel those out, we end up with, and unfortunately I've run out of room, but negative 1 over x times x plus h. So the difference quotient for the function f of x equals 1 over x is going to be negative 1 over x times the quantity x plus h. Let's do one more of these so we can get practice with another sort of example. This time let's look at f of x equals the square root of x. So here we're going to use the same formula, f of x plus h minus f of x over h. F of x plus h is going to be the square root of x plus h minus f of x is the square root of x all over h. And it might seem like there's nothing that we can do here to simplify things, but there actually is. We don't like the h in the denominator. In calculus, when we are dealing with this and we're kind of moving things one step further, the h is going to get smaller and smaller and get closer and closer to 0. And we know we can't have a 0 in the denominator. So it would be problematic to leave it like that. So we're going to want to somehow get rid of that. And there is a trick that we have here. What we're going to do is we're going to multiply the top and the bottom by the conjugate of what we have in the top. The conjugate of a difference is the same thing but with a sum. And so we're going to multiply this by the square root of x plus h plus the square root of x. And then the same down here, the square root of x plus h, plus the square root of x. And that is going to seem probably really weird, like where did that come from? But what happens, the reason we want to multiply by the conjugate is because when we do that, if we were to FOIL all of this out, the outer and inner terms would cancel because we've got plus root x plus h times root x, and we've got a negative root x plus h times x. So those cancel, and we end up with the product of the first terms, which ends up being x plus h, and then minus the product of the second terms, the last terms, which is x. A whole bunch of stuff cancels. The square roots all go away, and life is good. In the denominator, we have that h times the square root of x plus h plus the square root of x. And then in the numerator, we can see that the x's are going to cancel. X minus x is 0. And so we've got just h in the top, and then we've got h times that whole quantity on the bottom. And then we can even see that there's a factor of h in the top and bottom that cancels, which leaves us a 1 in the top. And then in the bottom, we have the square root of x plus h plus the square root of x. And that's the difference quotient for the second one. And we can also box in the one for the first one. If you're seeing difference quotients in one of your classes, depending on your textbook, depending on your class, depending on your instructor, you might look at some of these more complicated ones that end up with complex fractions or require multiplying by the conjugate, or you might not. You might just look at simpler examples that don't require either of these tricks. But I wanted to do one of each of these examples in the video just in case you're in a class that's doing something that's a little bit more complicated, so you can see an example of these sorts of tricks.